Okay, this video asked me to describe the transformations from the pre-image y equals open absolute value x plus 2, close absolute value minus 3, to the image y equals open absolute value x minus 1, close absolute value plus 4. Now, this one's different than the first two transformation videos in that we're not starting with the parent equation y equals absolute value x. So our first equation we need to graph is the pre-image. So let me go ahead and get the plane again. And I'm going to graph the pre-image y equals open absolute value x plus 2, close absolute value minus 3, the vertex of which is, of course, negative 2, comma, negative 3. Remember, we flip the sign of what's inside here. If you treat this like the number positive 2, then this becomes negative 2. And if you treat this like the number negative 3, it stays negative 3 out here. So the vertex is left 2, 1, 2, down 1, 2, 3. So for the pre-image, the vertex starts at negative 2, negative 3, and then it has a right-hand slope of positive 1. So when I go up 1, I'll go over 1. Go up 1, over 1. Up 1, over 1. And the axis of symmetry is x equals negative 2. So all these points are reflected about the axis of symmetry. Should appear about in the same position here and then over here. So here's the graph of the pre-image. Great, so that's a good start. Let's go ahead and get the graph of the image, what we want to get to. So we want to go from the pre-image to the image. And it has a vertex of positive 1, comma, positive 4. So remember, switch this number if you view it as negative 1 and keep this number the same. So the x component is just the flip of this number, negative 1, to positive 1, and the y component is just positive 4. So I'm going to go right 1 and then up 4. 1, 2, 3, 4. And it's located right here. And it, of course, has the same slope to the right and to the left. Positive 1, well, to the right and left of this one, the same as this one. So its slope to the right-hand branch slope is positive 1. Its left-hand branch slope is negative 1. So these should look about the same width. Obviously, I'm not great at drawing to scale, so they're a little off. In fact, this looks a little curved when in fact it should look straight. So let's describe how to get from here to here. The only thing I'm going to need is translations. There's no dilation or reflection. So I'm going to have to go over a certain amount. Let's see. I'll have to go over, so to the right, 1, 2, 3. So that's a shift to the right 3. So that's a translation. So horizontal, translation, right 3. So that moved this guy to the right 1, 2, 3, and it's right underneath this green guy here. So let's put what this transformation did, this translation, shifting it to the right 3, put it 1, 2, 3 right here, and it has the same width. So now to get from the red one to the green one, so I've shifted the blue one over to the right 3, it now looks like the red one. It just needs to go up. Let's count. 1, 2, 3, 4, 5, 6, 7. So that's a vertical translation. Vertical translation up 3. So if I go horizontal translation right 3 and a vertical translation up 3, oh, no, way more than 3. Why did I say 3? I must have been looking at this and just started copying. Definitely not up 3. I believe we counted a different number than 3. We went up 1, 2, 3, 4, 5, 6, 7. That's a vertical translation up 7. Okay. So, take this blue graph, and let's repeat this. We move it to the right 1, 2, 3, and then up 7. 1, 2, 3, 4, 5, 6, 7. It'll be in the same position as this green graph, which is what we wanted. Now, so of course my answer to this question, describing the transformations, here's the description of the transformations from the pre-image to the image.